Hey kids, today we're going to talk about isotopes and ions, which is just a little bit of building on where we were last unit, or last set of notes, when we talked about the atomic structure. When we talked atomic structure, we just touched on what an isotope was briefly, knowing that it's different versions of the same element, but we're going to zoom in on the two of these a little more today. Essentially, an isotope is going to be atoms of the same element that have different numbers of neutrons. And as you remember from last unit, basically they have to have the same atomic number, because all that is your number of protons. And remember that the number of protons defines the element. So in either of these cases up top, both of these elements are talking about carbon. Because they both have an atomic number of 6, they have 6 protons. However, if we go through and we look at the mass, this one's got a mass of 12 and this one's got a mass of 14. And if we remember that the mass number is equals protons plus neutrons, we know that if the protons stay constant, and in this case it's 6, we know that the thing that has to change is your neutrons. And so an isotope is just two atoms of the same element that have different numbers of neutrons. One can be heavier, the other can be lighter. Okay? And because we have isotopes, they will always have the same atomic number, but they're always going to have a different mass number, and the atomic masses. So when we get into this and look at the top right, obviously the carbon atom to the left has a mass number 12, mass number to the right is going to be 14. Atomic number to the left is 6, atomic number to the right is 6. So the atomic number is always the same, but the mass varies. Okay? And looking at examples here, take a second and see if you can figure out which of these represents the same element. So 1, 2, 3, or 4. Of those, which ones are the same element? So pause it. And from there, we should be able to go through and see that, what do we got here? Obviously, if we're looking at different masses, that doesn't affect me, that doesn't affect me, that doesn't affect me, that doesn't affect me. The only thing I really care about is our specific atomic number. That's a 92, that's a 92, and that's a number 92. And for those of you guys playing along at home, that means that 92 is a uranium. So that's this guy, and this guy. Your 93 right here is actually going to be neptunium. So while it may have the same mass as number 1, it's not even the same element. And yet number 1, number 3, and number 4 all happen to have the same atomic number and different masses. So there are 3 different isotopes of the same atom. Okay? And then the last thing we need to be able to talk about if we're going to actually draw these isotopes is that you've got to be able to talk about isotope notation. And basically what that means is that you've got the symbol, your carbon, with the mass number up top and the atomic number on the bottom. And I'm even going to show you a little hint. This goes through and does all of the math for you. If we're talking about carbon 14 with the atomic number of 6, one of the only questions I can ask you is, hey, how many neutrons are there? It's already set up as a subtraction problem. 14 minus 6 gives you 8. Okay, so this is 8 neutrons. So if you go through and remember that it's set up as a subtraction problem already for you, big on top, small on bottom, you should be able to figure out the neutrons very, very, very easily. Please don't screw that up, because we're going to write this in this very standard format all the time. So what I need from you is I need you to go ahead and take a second, so give the video a pause, and see if you can go through and figure out what the different numbers of protons, neutrons, and electrons are for these set different isotopes. Okay, so we've got 3 different isotopes of nitrogen. See if you can tell me how many protons, how many neutrons, and how many electrons are in each one. So give it a pause, or pause the video, and try it out on your own on your paper. No, seriously, pause it and try it out. If you can still hear me, you didn't do it. Alright, so let's try these out. If we talk about protons, we know that each of them is nitrogen, so they've all got to have 7 protons. So that's standard across the board. I don't even have to think about that. The neutrons, however, are where we get our little subtraction problem. I had a mass of 14 and 7 protons, so I know that my neutrons are going to be 7. 14 minus 7 gives me 7. In this case, I've got 15 minus 7, which means it's going to be 8. In this case, I've got 16 minus 7, which is going to be 9. And hopefully, as you remember from last lecture, the number of electrons, given that we have a neutral atom, and you're supposed to assume it's neutral, especially because I haven't given you a charge anywhere, the electrons are just going to equal your protons. So we should go through and we should have our electrons be 7, 7, and 7. Okay, so that should have been pretty easy. Hopefully that's stuff you can fill out a little more in depth. Come in class and we'll go through and you'll actually have to draw out the isotope notation and charges and all that stuff, but those are future problems for future you. Let's work our way down to what an ion is. The second half of our unit is actually going to be, our second half of this lecture is going to be on ions, which are basically a charged atom or group of atoms that have a positive or negative charge. Okay, basically an ion differs because it now has a different number of electrons, and what that's saying is that if you happen to have, let's say, it was originally neutral, so we had our 3 and 3 protons and electrons. Okay, we now, to create a positive or negative charge, you've got to take away an electron or you've got to gain an electron, because I can never change the number of protons. Can't happen. Electrons, I can gain and lose, and that's actually how bonding occurs. We're going to talk about that a little more in the next unit. But if I go ahead and I gain an electron, I now have more electrons and have become negative. If on the other hand, I lose not just that one that I gained, but I lost the original, so I'm down to 2 electrons. Okay? If I lost electrons, I now have 1 less electron than the protons, making this whole balancing act positive. Okay? And that's where we're going to go in the next couple of moments here. So if we go through and think about a neutral atom, the number of electrons equal the number of protons, and we just hit that, with our 3 and 3. But for an ion, the protons are going to be the same, but your electrons are different, and we either gain or lose the electrons, and that's very, very, very key. So for the neutral atoms, we're never going to go through and list the charge, just sodium, calcium, iodine, oxygen. When we talk about an ion, however, I'm always going to list a charge up in the top right-hand corner. It is always written in the top right-hand corner. Okay, so we've got sodium +1, or with a positive charge. Calcium with a positive 2 charge. And what this guy means is this means that we have 2 differences between the protons and the electrons. So this has 2 less electrons. We've got an iodine minus, or -1, or with a negative charge. Okay, and that means that we have 1 more electron. And this guy means that we've got 2 more electrons with that oxygen. Alright, so we have different types of ions based on whether an ion is losing electrons or gaining electrons. Basically, if we lose an electron, it becomes positive because there are now more protons, and we call that a cation. Now, how do I remember that? This might be stupid. Well, it is stupid, but cats are positive. Yay, everybody loves cats. Is that true? Yeah, probably not. But helps me remember. Okay, so cats are positive, so I know that my cation is always a positive charge. The other option for ions is, however, continue with the cation. Obviously, if we go through and we talk about a magnesium atom, so if we got this magnesium atom to the right that's got 12 protons and 12 electrons, if it happens to lose 2 of those electrons, dropping it down to 10 electrons, it would become magnesium 2+, because as it loses electrons, it loses negative stuff, and that means you're going to have more positives involved on that given atom. So like I jumped a little forward, obviously if we go through and we talk about adding electrons, we're talking about an anion. Okay, so adding an electron to an atom gives it a negative charge, and this should make sense if we start off with that lithium atom we keep talking about with 3 electrons, or 3 protons. Woo. And then I go through and I have my 3 electrons. If I gain 1 more electron, that puts me at 4. And if we think about our magical balancing act here, there are more electrons. So this is a more negative. Okay, so more negative means that we have a negative charge. Okay, so gaining an electron means you've got a negative charge. And we call that an anion. And the way I like to think about this is onions are bad. Now, obviously, you might agree with that just as much as you agree with cats being good. Actually, you probably agree with neither of those, but that's besides the point. But this is how I go through and remember. Cats are good, onions are bad. And if I kind of think of that the cats are positive, the onions are negative. Okay, and that helps it keep me straight. And if you don't agree with it, you can still remember it that way. Anyways, an example of that would be if we happen to have a fluorine atom to the right that has 9 protons and 9 electrons. As it goes through and gains an electron, we kick ourselves up to 10 electrons. Okay, and that's going to become F minus, okay, or F negatively charged. So it's got 1 more electron than the protons. Okay. And obviously we can do the exact same thing with the ion isotope notation, trying to figure out how many protons, how many neutrons, how many electrons we have. So take your potassium, take your oxygen, take your calcium, pause the video, and scroll through and see if you can figure out how many protons, how many neutrons, and how many electrons. No, seriously, pause it. Do it, because practicing is how you learn, kids. Anyways, I'm going to assume that you actually went through and tried these. So if we look at potassium here, we've got 19 protons, as given right there. We're going to end up having, switch to blue, the neutrons are going to be a 39 minus the 19, your mass minus your protons, so we're going to be at 20. And your electrons are going to be based on this. So we should have 19. Problem is you know that this has a positive charge, so it's not really 19, but we have 1 less, so it's going to be 18. Okay. And over on the oxygen here, I know that I've got 8 for number of protons. I know that my neutrons are the 16 minus 8, giving me a 8. Nice and easy. 8 plus 8 gives us a 16 for the mass. And again, we know that our electrons should have been 8, because they're the same as protons. But with that minus 2 charge, I know that I have gained 2 electrons. So it's no longer 8, it's 10. Okay, and hopefully you guys are following along with this stuff. And again, our final one, our calcium. We know the protons are 20. We know that the neutrons should be our 41 minus 20, giving us a nice little 21. And our final set here is the electrons involved. We know it should have been 20, but having that plus 2 charge means that we lost 2 electrons, so it's not 20, it's going to be 18. Okay. So hopefully that makes sense. You should be able to fill all those in. And we're going to just end it on a nice little comic for you guys because, well, they're amazing. This is just another casualty of the War of the Atoms. I'm just going to let you read for yourself. Anyways, have a wonderful day, children. We'll do it again, I don't know, next set of notes.